All right, so we're looking at the second part of word problems. And example one, that's one that I had you guys do. I did that class yesterday, but in case you weren't here. You pause the video, read it, mark your sides, and figure out which trig functions you're going to use. But you have a ladder that's 110 feet, so that's the ladder, 110. And it goes up 104 feet. Okay, so we have this right triangle. And we want to know the angle of elevation, so that's that angle right there. So we have an opposite and a hypotenuse. And we want to find that angle, so we'll use arc. But this is before you thinking of arc, but the sine of this angle would be the opposite over hypotenuse. So since we want to know the angle, we'll use arc sine. Put that into Desmos, and you get about 71 degrees. Okay, and now the next part is how far is it from the base of the ladder from the building? So we want to know this distance. So in relation to this angle, that's the adjacent. So we can use with opposite over adjacent, or we can use adjacent over opposite. So we can use tangent or cosine, or we can even use Pythagorean theorem. Okay, but I'm going to use the cosine of this angle. Okay, I don't like using this angle because it's a rounded number. I should use Pythagorean theorem, but I've done them both, and we get the same number if we round it to 10. So I multiply both sides by 110, and I get 110 cosine 71, which is 35.8. Doing word problems, so we need units, so it's 35.8 feet. So in context, the ladder is about 35.8 feet from the base of the building, and the angle of elevation is about 71.0 degrees. Okay, this is your turn. Pause the video, try the problem, and then press play. Okay, so the ladder against the house reaches 15 feet up. Okay, it's 13 feet away from the base of the house. What angle does the ladder make from the ground? So we want to know that angle right there. So in respect to this angle, we're given an adjacent. We have the hypotenuse as well. So an adjacent and hypotenuse, opposite, that's opposite. So we have an adjacent, we have an opposite. We're going to use tangent. So since we're finding an angle, we're going to use arctangent, which gives us 49.09. I know I rounded to the hundreds. You can round to the tenths, it's fine. Okay, so that's my angle. Now we want to find how tall the ladder is. We should use Pythagorean theorem. Okay, but I think I'm going to end up using either cosine or sine because I want to find the hypotenuse. And both of those trig functions include hypotenuse. So I'm going to use cosine. Okay, so this one here, we have cosine of 49.09 degrees equals adjacent over hypotenuse. So this is one where the variable's in the denominator, so we're going to bring this over, and then we're going to divide by cosine of 49.09. And so we end up with x equals 13 over cosine of 49.09, which is about 19.85 feet. Okay, so the ladder is about 19.85 feet tall, and the angle of elevation is about 49.09 feet. 49.09 degrees. Okay, example 2, we've got an observer in the lighthouse. He's located 300 feet above water level. That's 300 feet. He spots a boat 1 mile offshore. Now, wait a minute. It's a problem. Oh, this one says 300 feet. This one says 1 mile. They don't have the same units. Okay? So for us, we're going to convert this mile to feet. Okay, we want to find the angle of depression to the boat. So if you were looking straight ahead, what's that angle to the boat? Okay, so what I'm going to do is I'm going to find this angle first and then use its complement, which will give us the angle theta. That's what we're looking for. Okay, so remember, the angle of depression comes from the horizontal line to the line of sight we're looking for. Okay, so we'll use the fact that 1 mile equals 5,280 feet. We've got to do that. We can't use different units. And then we have this angle, or we're trying to find this angle. We're given this part and that part of the triangle. So which parts are we given? We're given opposite. We're given adjacent, which means we would use arc tangent. Which gives us about 86.75 degrees. Again, I rounded to the hundredths. You can round to the tenths. So I need this angle though. So this is a vertical line because that's height. This is the horizontal line from creating the angle of depression. So they are perpendicular, which means they add to 90. So 90 minus 86.75, which is 3.25 degrees. So we can say the angle of depression to the boat is about 3.25 degrees. Okay, example 3. We got this airplane leaving the runway. Its angle of climb is 21 degrees, which is an angle of elevation, and its speed is 250 feet per second. So for every second, it's traveling 250 feet in that direction. So let's go ahead and mark that angle of climb 21 degrees. It says find the plane's altitude after 1 minute. So we want to know what that height is, that altitude A, after 1 minute. So this after 1 minute is going to come into play when we look at the speed. So for every second that goes by, this plane is traveling in this direction 250 feet. So after 1 minute, there are 60 seconds, which means there are 60 250 feet. So we know this hypotenuse by multiplying 250 times 60, which of course is 15,000 feet. So we want to find the altitude or the height there. We're given this angle, we want to find the opposite, and we're given the hypotenuse, so we use sine. Not arc sine. Arc sine would be if we're trying to find the angle. We're not trying to find it. So let's multiply both sides by 15,000. And we end up with 15,000 times sine of 21 degrees, which is about 5,370 feet. Which we just learned from the previous example would be a little bit bigger than a mile, right? Because a mile is 5,280 feet. So the plane's altitude after 1 minute is about 5,370 feet. Okay, and here it is in class. We've got some homework. You're going to say, I'll finish this at home. And then at home, I'll finish this in class. That's funny.